Good morning, all. Today's topic is pile foundation. So, we already know that foundation is a substructure that transfers the load from superstructure to the soil that is present below the foundation. So, foundation is a substructure that transfers the load from superstructure to the hard strata that is present below. Hard strata or hard soil that is present below, and from there the load distribution is regular or uniform. And foundations are classified into shallow and deep foundations. Shallow foundations means the foundations whose depth is less than or equal to width of the foundation are called shallow foundations. And coming to the deep foundations, the depth of foundation is greater than width of the foundation. So the foundation whose depth is less than or equal to width, they are called shallow foundations, and the foundation whose depth is greater than the width, they are called as deep foundations. The examples of shallow foundations are mat, raft, isolated footings, combined footings. All these comes under shallow foundations. And coming to the deep foundation, the best examples are pile foundations and well foundations. Today let me explain about pile foundation. This is one of the important deep foundation used for load transfer mechanism from superstructure to the hard strata, deeper hard strata that is present below. Yes. Brief outline about this topic is definition of pile, classification of pile, pile capacity and settlement of pile groups, lateral loaded piles, that is seismic consideration, and summary. And coming to the piles, what is the meaning of pile? Piles are columnar elements in a foundation which have the function of transferring the load from superstructure through weak compressible strata or through water onto stiffer or more compact and less compressible soils or onto rock. That is about piles. When we need to use piles, that is one more thing. So when the strata at or just below the ground surface is highly compressible and very weak to support the load transmitted by the structure, during that case these pile foundations are very much necessary. When the plan of the structure is irregular relative to its outline and load distribution, then also we have to adopt pile foundation. And the pile foundations are used for the transmission of structural loads through deep water to a firm stratum. And pile foundations are used to resist horizontal forces in addition to support the vertical loads. And when the soil conditions are such that a washout or erosion or scour of soil may occur from underneath a shallow foundation, then we need to use pile foundations. So and also to resist uplift forces, transmission towers, offshore platforms. Mainly the uplift forces occurs in transmission towers, offshore platforms, and some other taller structures. In that cases uplift forces are very much common, and to resist that uplift forces these pile foundations are very much necessary. And while constructions are done at expansive soils, they easily swell or shrink as the water content changes. The swelling or shrinkage as the water content changes occurs in expansive soils. To overcome this problem, for buildings in expansive soils, pile foundations are very much used. And coming to the examples, some examples: multi-storied building resting on pile foundation. This is a clear-cut example. So pile foundations are majorly used for multi-storied buildings. So the building is like this when they rest on the pile foundations. And some more examples are piles used to resist uplift forces. Mainly the uplift forces concept occurs in transmission towers and also underwater structures. So the structures which are constructed underwater these uplift or anchor piles are used to resist them or protect them. And coming to the transmission line towers, compression piles or uplift piles are used to safeguard these structures. So piles are used in these structures frequently. And few more examples are, during the construction of retaining wall, a batter pile is used and that have horizontal loading systems. And bridge piers, while constructing the bridge piers, these piles are also used. These piles are also used to resist lateral loads. In the above two cases, piles are used to resist vertical loads, and coming to the third case, piles are used to resist horizontal or lateral loads also. And coming to the classification of piles, piles are classified into different categories based on material. First of all, let us see the classification based on material. Steel piles, concrete piles, timber piles, composite piles. Name itself indicates the piles that are made with steel are called steel piles, and the piles that are made with concrete are called concrete piles, and the piles that are made with timber are called as timber piles. And combination of any two materials, like top portion is filled with steel and bottom portion with concrete, or top portion is manufactured with concrete and bottom is with steel, timber and steel, any two materials combined to prepare piles, then they are called as composite piles. So based on material, piles are categorized into steel piles, concrete piles, timber piles and composite piles. Based on load transfer, piles are classified into end bearing piles, friction piles, combined end bearing and friction piles. So the piles completely transfers the load from top to bottom, and from the end they will release the loads. That is about end bearing piles. And coming to the friction, while the load is transferring from top to bottom of the pile, in the middle itself, through skin or through its sides, load get distributed. That is the concept involved in friction piles. So end bearing piles completely transfers the load and release the load at its bottom uh, ends, and friction piles release the load from its side. Combined end bearing and friction piles is the third category of classification based on load transfer mechanism. In this case, load is transferred from top to bottom, and some amount of load get released at its tips, and some amount of load is released while coming itself through its sides. This is the combination of end bearing and friction. End bearing means at pile tips load will release. Friction means at the skin or sides of the piles load will release. Combined end bearing and friction means some amount of load gets released at the tips and some amount of load gets released at the skin. So this is the load transfer mechanism, classification of piles based on load transfer. And coming to the classification based on method of installation, driven piles, driven cast in situ piles, bored and cast in situ piles, screwed piles, jagged piles. These are the classification based on method of installation. Based on use, piles are classified as load bearing piles, compaction piles, sheet piles, fender piles, anchor piles. Based on the purpose where we are going to use these piles, they are classified into load bearing piles, compaction piles, sheet piles, fender piles and anchor piles. And coming to the based on displacement of soil, piles are classified into displacement piles and non-displacement piles. These are the major classification. Classification based on material, classification based on load transfer, classification based on method of installation, classification based on use, and classification based on displacement of soil. And coming to the selection of pile, length of pile in relation to the load and type of soil. So piles are selected based on length of pile required in relation to total amount of load that is to be carried, and also upon what type of soil the construction is being done. So based on this selection of piles here done, character of structure, availability of materials, type of loading, factors causing deterioration, ease of maintenance, estimated costs of types of piles, taking into account the initial cost, life expectancy and cost of maintenance, and availability of funds. All these factors plays a very important role for the selection of piles. So length of pile in relation to load and length of pile in relation to load and type of soil, character of structure, availability of materials, factors causing deterioration, ease of maintenance, estimated costs of piles taking into account the initial cost, life expectancy, and cost of maintenance, availability of funds. All these factors are to be considered while selecting the piles. And coming to the load transfer mechanism, single pile load transfer mechanism and load transfer curves are shown here. So when the load QU is applied, some amount QF and QB, so end bearing and friction, both loads, and at the same time total length of pile is considered as L and the diameter is taken as D. And here clearly you can see the curves are showing the loads carried by the pile shaft. So this is about load transfer mechanism. And one more load transfer mechanism, here we can clearly see a curve that shows load versus settlement curve, and load, and as the load changes how the settlements is going on, we can clearly see in this figure. These load settlement relationships are for large diameter bored and cast in situ piles. Coming to the types of failures of piles, we can see buckling because of very low strength, buckling in very weak surrounding soil. When the surrounding soil of the pile is very weak, the buckling is the failure mechanism. We can clearly see in the piles. In the figure we can clearly see how the buckling is happening. And coming to the general shear failure in strong lower soils. So in strong lower soils, the lower soils which are strong, in that case general shear failure is the major failure occurring. And coming to the soil of uniform strength, if the soil is having uniform strength, this type of failure may occur. Next, low strength soil in lower layers, skin friction predominates. So when the soil in the lower layers is of low strength and also skin friction predominates there, then the failure is going to happen like this. Pile mechanism, pile placing, and also curve is clearly shown. And types of failures of piles. Skin friction in tension. So when skin friction is in tension, during that case also this type of failure occurs. Load carrying capacity of piles, clearly we can see. So static pile formula we are having with C pi parameters and standard penetration test value, and using standard cone penetration test value, this in situ penetration test. So static formula can be used for calculating load carrying capacity of piles, and in situ penetration test can also be used. In situ penetration test like standard penetration test and static cone penetration test. So these tests can be used for load carrying capacity of piles, and also by using dynamic formula we can calculate load carrying capacity, and pile load test is the best test for calculating pile load carrying capacity. And coming to the static method, QU is equal to QP plus QF, and QU means ultimate failure load, QP means point resistance, QF means shaft resistance. This one already we had seen. And QS is shaft resistance developed by friction between the soil and pile shaft. And static method for driven piles in sand, end bearing capacity can be calculated using this formula, and frictional resistance and ultimate load QU is equal to QNQAB plus K sigma V tan delta AS. These are the formulas for calculating load carrying capacity of driven piles in sand. Next, static method for driven piles in clay. End bearing capacity can be calculated by using QP is equal to CNC. QP is equal to CNC, and frictional resistance QS is equal to FSAS. Net ultimate load QU is equal to CNCAB plus FSAS. So these are the static formula for driven piles in clay. And the problems can be like this. While concrete pile diameter had given, and that is driven in sand of loose to medium density at a depth of 15 meters. Following properties like average unit weight, length, and average pi value, ks, everything is given. And now they are asked to calculate ultimate bearing capacity and also allowable load. Water table can be assumed to a greater depth. So the problem like this may occur. Thank you.